students, this is a lesson on, I'm doing this a short video on what is the meaning of scalar and vector projection. Lesson 9.2, class 189. This is, so what is the scalar projection of vector u bar, so the vector u and v? And you can see that I've taken exactly two vectors, the vector u and vector v, beginning from the origin. So they are like the position vectors also. So u bar and v bar are projection vectors. U bar, v bar are position vectors. What is the meaning of position vectors? Means the vectors, the starting point is the 0, 0. Now in this case, I did it in such a way. So this is 6 and this is 8. So I took the point maybe 6 and 8, the coordinate of this point u. So the uppercase stands for the point, the black point here. So here let me do this dot basically means 12, 5. So 12 and this is 5 right here, this is 5. So I took this on purpose because 6, 8, 12, so 6 and 8 and 10 make a Pythagorean triplet, and also 5, 12, 12, 5 and 13 make a Pythagorean triplet. So the reason is we need to know the magnitude of these two vectors, the red and the. Okay, so from earlier classes we know what is the definition of is dot product. So we know this is the magnitude of the first vector, magnitude of v, and times cosine of the angle, right? So that's the definition. And then we also see, which I'm going to make a separate video, is y dot v. So if there is a u is given by a vector within the component form a1, a2, and v is given in the component form b1, b2, then the vector becomes a1, b1, comma a2, b2. So we're going to apply this in that concept. Okay. First is what is the scalar projection. So that if you see this, the definition of scalar projection is nothing but, if you want to know what is the scalar projection of this red vector along the v, so you drop a perpendicular. So you drop a perpendicular, and then you can see it makes a 90 degrees. And by definition of cosine, if the angle between the two is theta, this is the angle between the theta, and this is the adjacent, and you can see cosine theta. So cosine theta is the magnitude. This magnitude is this one. So it is the whatever. We don't know how much is this. So I'm gonna make it like okay, call it like m, and so this is like om. So I write om and divide by the magnitude, correct? And you just multiply by 2, so you multiply the same thing on both sides, and you kind of get that this goes away, and you get the projection. And that projection I want to use kind of a squiggly thing. So this is the projection, which is u bar. So this is that u bar, vector u, magnitude, into cosine theta. Now, mind you, this is only from this to here. Okay. So that is the projection. And so let's write down what is the scalar projection of vector u on this is the answer is so we can write it like projection of u, vector u on v bar. So this is how we write, and that is nothing but u bar. So the magnitude y into cosine of theta. Is that okay? Now what I'm going to do is, this is the project. That's it. Our next goal is we can write this also. So this is same as magnitude and cosine theta, and I can multiply and divide this by v bar, this magnitude, the v bar. So this is the vector v, the black color. So the black color, let me use the magnitude and divide it by So the same number. So I'm multiplying and also dividing by the magnitude. So when you write this, this becomes u bar, and because this is all multiplication, I can use commutative rule and you can write this right here, and cosine theta, and this becomes the black color with this magnitude. And the top part, by definition of dot product, we can write it as u bar dot v bar divided by, so this is projection of u bar over v bar. Once we know this, then comes what is the meaning of vector projection of vector. So this is scalar product. This is the magnitude. And this is the, or you call it scalar. It's just the distance. So it is just the orange distance from this O to this M. But now we want to know what is this vector. So we need to know what, in what direction is this. So it is along the V bar. So this is V. But we want to know the how much, what is, how do we write this in the vector? So for that, remember the trick is we need to know, let's say there is a vector like this. There is a vector from, let me do this way, see, if this is a vector like this, and it has a magnitude of 5, and this may be 4 and 3, you can see, I'm just using the easy one, 4 and 3 makes a Pythagorean triplet, because 3 square plus 4 square is 5 square, right? So if I say 4 and 3, and say, okay, now what is this direction? So we know what direction is this. Can we find a vector along this one, the unit one? I can break this into 1, 2, 3, and 4, 5 pieces. So we want to know how much is this part. So all you do is, if you know this is 4 and 3, so this is the vector, this one. So the unit vector along this will be that 4 by 3. So you have to divide this by, and divide this by like this. In other words, what I'm trying to say is, this unit vector is, whatever the vector is 4 and 3, all you do, you are dividing this by the magnitude. That means the magnitude is whatever is 5. So when I say if this is the vector O to V is the O to V, we need to know what is the unit vector there. So the next, so this is the ending part I'm saying. What is the vector projection? So projection, vector projection, sorry, that's right. Projection vector of, oh, it's already written down. So in short, we write PROG, projection vector of U bar over V bar. See this? So it is a projection vector of this one over this. So this is the magnitude. We want to know the direction. The best is, I'm going to use this O to V. This is V, the vector. So this is vector this. So all you do is divide by, to get the unit vector, I have to go right here. So this is the unit vector. See this piece? We want to know the unit vector. And how do we figure that out is, so this is the unit vector. We want to know how much is this piece, and then we can break it up into those many that make up to U bar cosine theta. So this is equal the magnitude wise. So the magnitude is already here, right? Here, this is the magnitude, right? So it is U bar dot V bar over V bar. This is the magnitude, but we need to multiply the unit vector. And how do we multiply? What is that unit vector is? Whatever that vector is, you divide by the magnitude. So if this is the vector, the 12 and 5, this, of course, I'm not taking the numbers right now, I'm just taking V bar. So this becomes the vector V bar along that and its magnitude. So that's the beautiful thing happening is projection vector is how much is the projection times the unit vector along that. So in other words, we can see there is, as you know, these two magnitudes are the same, and you kind of get a formula, projection of vector U over V bar is, this will be U dot V bar, and these two things will give you this way, See? So that's the square, so there are two of them. This whole thing is like a number, and number scalar times that, whatever that's, those, this V bar. So basically what's going on is to get the projection vector, you do all this stupid work and then you just take the vector. In this example that I gave is, let's see, the example that I showed here is in this case is, okay, let's apply this. How do we find what is this projection vector? So we want to know how much is this part. My goal is, what is the projection vector? Let's do that. So this is the formula. So the answer is, u bar dot v bar. So you have those two things. So this is like a a1, a2, and this is b1, b2. So when you want to do dot product, you multiply this 6 times 12. So multiply 6 times, so it is 6 times, star is multiplication, 6 times 12 plus, and then you multiply the 8 and this one. So 8 times 5. Okay. So that is the top part, and the bottom part is the magnitude of the V. Now this V magnitude here, let me write this. The vector OV is the vector. Okay, but then you want to know the smaller lowercase I use to represent the vector. But if you want to write a magnitude, you know it is. This is 12. This is 5. So it is 13. So Pythagorean triplet said this is 13. So the V bar is 13 square. So it is 13 square. And then in the vector here is 12 and 5. So this is 12 and 5. So your answer becomes 74, 6 times 72 plus 8 times 40 and 169, 12, 5. And this will be 72 plus 40 will be 112, I think 112, 16, 12, 5. And if I reduce this by 2, 2 goes 5 times, 2 goes 6 times, 2 goes, I think 4 also divides, so let's divide by 4. 4 times 4 is 16, so, and 4 goes 3 times, 4 2 times 8, and 4 8 times. Oh wow. So 4 go for 16. I want to make sure I'm doing it right. Bell rang. I'm just finishing. So 4 goes to 8. What do I do? 8, 3, 5. Oh, 4, and then 4 becomes 7. So basically, this is nothing but this is 7. Get the whole thing, and then it is 12 and 5, and you just multiply 7 and 2 is 4 1, so 84 and 35. So that's the projection vector. I want to make sure I'm doing it correct. This is 40, yeah, correct. And is it really true that I divided by 7, right? 16 and 7. 7 is 42, correct? 7, 8, 9, 10, 11. Yeah, that's right. That's cool. So we don't get a fraction here. Hope this helps video. So this video is made just to understand. Let me walk through quickly as the students are coming for my next class. This is about understanding what is a scalar projection means, what is a vector projection. If it is a scalar projection, we use our regular trigonometry that it is u, whatever this hypotenuse, you just multiply cosine of the hypotenuse, you get that. And then I try to multiply up, down, the reason to get a dot product. So with the help of a dot product, I do this. Then I use the other one is cross the projection vector. By definition, it is multiplication by the unit vector. That's the unit vector. And then when you have these two things multiply, and you just apply all this. This is just an example that the first vector is 6, 8, 12, 5. This is A1, A2, B1, B2. Just apply this formula. You plug it in here and you get this part. This is the magnitude of the vector, the big black color. So you just square it, 13 times 13. Oh, I think I made a mistake here. This is 13 times 13 is 169. So everything goes wrong here. So I just want to see this answer is 112, 169, and 12, 5. and then you just divide this. So you multiply this two and you get the final answer. And that's the projection vector along them. I'm so sorry. Yes, thank you so much for keep watching the videos that help you to understand the vector calculus. So next one I'm gonna do is what is. So the next goal is, can we understand is also what is E cross vector cross product of two vectors. We'll see in the next time. Thank you.